Hello viewers, in today's lecture we are going to take an important topic, that is foot of the perpendicular drawn from a given point to a given line, right? So here we have a line L whose equation is given here, x plus 3 by 5 equal to y minus 1 by 2 equal to z plus 4 by 3, right? And here the given point is given as 0 comma 2 comma 3. So the coordinates of the point P are 0 comma 2 comma 3. Now from this point P we have dropped a perpendicular on this line L, and the foot of the perpendicular is M, right? And our aim is to find the coordinates of this point M, right? And the length of the perpendicular, that is PM. Clear? So here we have two aims. The first one is the coordinates of the point M, which is also the foot of the perpendicular, and the length of the perpendicular, that is the line segment PM. And here this is 90 degrees, right? Okay, so let us suppose that the coordinates of this point M are alpha, beta and gamma, right? And the equation of the line is given here, and let us take here a scalar lambda, right? So x plus 3 divided by 5 equal to y minus 1 divided by 2 equal to z plus 4 divided by 3 equal to lambda. And here one important thing is the direction ratios of the line L are 5, 2 and 3, right? Now here we have equated these three ratios, that is x plus 3 by 5, y minus 1 by 2 and z plus 4 by 3 equal to lambda. So we can write x plus 3 by 5 is equal to lambda, and then we have y minus 1 by 2 is equal to lambda, and then z plus 4 divided by 3 is equal to lambda, right? So if we solve these three equations for x, y and z respectively, then we get x plus 3 is equal to 5 lambda. So x is 5 lambda minus 3. Similarly here y minus 1 is equal to 2 lambda. So y is 2 lambda plus 1. And here we have z plus 4 is equal to 3 lambda, that is z is equal to 3 lambda minus 4. Now viewers, here these points, that is x, y and z, this denotes a general point, denotes the coordinates of the general point, coordinates of the general point on the line L, right? And say this point is represented by this point M, right? So let us suppose that the coordinates of M are alpha, beta and gamma, and this alpha, beta and gamma are equal to x, y and z, that is 5 lambda minus 3, 2 lambda plus 1 and 3 lambda minus 4, right? So this is 3 lambda minus 4. Clear? So alpha is 5 lambda minus 3, beta is 2 lambda plus 1 and gamma is 3 lambda minus 4. Now we see that this line segment PM is perpendicular to the line L, and let us first find the direction ratios of this line segment PM, right? Now the coordinates of point P are 0, 2, 3, and the coordinates of M are 5 lambda minus 3, 2 lambda plus 1, 3 lambda minus 4. Now the direction ratios of PM, right? The direction ratios of PM are given by x2 minus x1, y2 minus y1, and z2 minus z1, because we know that if the coordinates of point P are x1, y1, z1, the coordinates of point M are x2, y2, z2, then the direction ratios of the vector PM is x2 minus x1, y2 minus y1, z2 minus z1. So here we have 5 lambda minus 3 minus 0, we have 2 lambda plus 1 minus 2, 3 lambda minus 4 minus 3, so this is 5 lambda minus 3, this is 2 lambda minus 1, and this is 3 lambda minus 7, right? Okay, now since PM is perpendicular to L and the direction ratios of the line L are 5, 2 and 3, and we know that if two vectors are perpendicular, then the condition is a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? So here a1 b1 c1 are the direction ratios of the vector PM or the line PM, and a2 b2 c2 are the direction ratios of the line, right? So we have 5 lambda minus 3 times 5 lambda minus 3 multiplied 5 plus 2 lambda minus 1 multiplied 2, and 3 lambda minus 7 times 3, and this is equal to 0. And here we have 25 lambda minus 15, this is 4 lambda minus 2, this is 9 lambda minus 21 is equal to 0. Now if we solve this equation for lambda, we get 38 lambda and minus 38 is equal to 0, and 38 lambda equal to 38, so lambda is equal to 1, right? So once we have obtained the value of lambda, we can easily find the values of alpha, beta and gamma, right? Now if we substitute this value of lambda here, we get the values of alpha, beta and gamma. So we have 5 times 1 minus 3, this is 2 times 1 plus 1, and this is 3 times 1 minus 4. So this is 5 minus 3, this is 2 plus 1, this is 3 minus 4. So this is 2, this is 3, and this is minus 1. So the coordinates of point M are 2, 3 and minus 1. So this is the foot of the perpendicular, and the length of the perpendicular PM can be calculated by making use of the distance formula, that is x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, right? So the point P is x1 y1 z1, and the point M is x2 y2 z2. So we can write 2 minus 0 square plus 3 minus 2 square plus minus 1 minus 3 square, right? Now if we calculate this expression, we get 4, then we get 1, and then we get 16, right? And this is equal to square root of 21. So the length of the perpendicular PM is square root of 21 units. So viewers, this is how we proceed, and this is the method to find the foot of the perpendicular drawn from a given point to a given line and to find the length of the perpendicular.